Now looking at the function of the economic model, again we have the income distribution of 2016 uh, and the wealth distribution of 2016. We can choose to start with these, but just for starters, we will start with an egalitarian population, each making what the average person was making in 1989, each paying what the average person was paying in 1989, with standard incomes throughout. Also, what the average person was making in 1989. So to restart everything, you just have to click on the play button under the standard distribution. The two files that are necessary, of course, will be submitted. And before clicking this one, of course, every bit of code before that should be clicked. So that restarts everything. Then pressing this play button will start the simulation. So we are here, and we start with everybody having somewhere around $290,000. This is in the thousands. So then we're in 1999. We want to get to 2020. So the idea is to click it 31 times, right? So 3 years. We're in 1992 now. We start to see some people that are wealthy than others, likely thanks to the entrepreneurial chance distribution, the Poisson distribution. 1994, 5, 6, 7, 8. We're gonna party like it's 1999. Happy 2000s. As we see, the wealth has overall increased. People are overall richer. In this simulation, there is zero corruption to democracy, and there is zero increase in the expenses. So these people should just overall get richer, right? And we can see that 2001, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 years from home, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This would be today, in theory, if the model were accurate, and if everyone's income were to change in such a way that the increasing cost of living did not affect them, right? And in a way that there was no corruption to democracy in this model. We do have some outliers. There is somebody making, I believe that is $1 million. No, holding $1 million, starting at about 200,000. Everybody, and there's somebody holding 500,000. But that is not an inequality I am not okay with, right? So, just for the purpose of extremes, this will be done 3 more times. Once more with grade inequality and the same starting data, and once more with grade equality and the current US values starting data. So let's do that. To put grade inequality, we would put a 1 here, right? And we have to restart the distribution. So we would run this, and we would run this 31 times. Again, everybody said about $290,000. Why the distribution looks like such is a problem with Seaborn. I will not think about that. We want to click it 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the year 2000. There's great inequality, and we can see that the distribution is already pretty broad. Last time in the year 2000, we were not so distributed that we had somebody having $700,000 at this point. We still have 20 years to go, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Here we are still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this would be the year 2000, right? Even with the great inequality, um, we see that there is still not a crazy distribution, right? The richest person now is worth about 1,100,000, and the poorest person is still around the 500,000. It is not an insane amount of inequality. If one were to increase this expense rate value, that would change when you generally increase it above 5%, which is the general income growth ratio, per explained in the variables video. Then we just have everybody getting poorer and poorer, and some people manage to make it. So then you would see some people get crazy rich, but only because others are getting poorer. Now using the US data. To use the US data, it is not too complicated. You simply go up here to where life is created. Life is the great array that holds everything. And then you would just write US next to the wealth and US next to the income. All right. We will restart the distribution. Perfect. That's our society today. Allow it for 1 year to get rid of negative values. Okay. So it is not easy to see, but right here we have the top person holding 300, I believe it's 350 million. And we will see that the inequality increases. Yeah, so this is all in thousands, right? So this is 400, this is 4 million, okay, this is 4 billion, right? That is how the plan's doing. And if we run it with great inequality, we roughly see the pattern that we see in real life. Every year they just keep getting richer and richer, those that are filthy rich. And the majority of people really do stay kind of low, right? Nothing compared to the amount of poverty that we see in the 2016 wealth distribution, but with a 100% correlation between the proportion of wealth that you hold and your vote, we start seeing similarities between this distribution and the current distribution. And it just halts at inequality, but even this distribution with 100% inequality rather pushes everybody to the center, right? There are 1,000 people in this simulation, and it seems that there are only 3 of them that have extreme wealth, and the majority of them have moved towards lower values. Upon submitting this code, I will also have it print out the array of everybody's wealth, so one can see the numbers. But yeah, over time, even with great inequality, because of the functional tax system, the rich kind of fall back down, and it becomes normalized. And that is all I have to show. If you want to try this out, remember that this number here is the amount of corruption in democracy, 0 to 1. And this number here is the rate at which living costs increase per year from 0 to 1. Any rate significantly above 0.05 will cause the general population to get poorer and poorer until everybody just goes to the negatives. Something to keep in mind. Enjoy.